And finally, the last of the descriptive statistics, measures of normality. So the way to show normality in a study is usually with a graph. It is the easiest way to show that something is normal. But to start with normality, let me explain you as quick as possible what is normality. A normality is a distribution where most of your observations are in the middle, in the median. So this is the mean of your observations, and the normal distribution is that half of them are on the right and half of them are on the left. That's to start with. The other thing is that it also has this shape like this, that you have of course you have 50% of your observations here, 50% here, and the other thing is that maybe around here, between this and this, you have 55% of your observations. And if you do the calculations, the distance between this and this should be 1 standard deviation. I hope I am clear. Like, for example, if you go back to the idea of the grades, it should be that 80 is the mean, then 50% of the students should be in the right side and 50% in here. The next thing that we should check is that around here we have 1 standard deviation, and I think that let's assume that the standard deviation is 10. So 1 standard deviation is the distance between this and this, and it should be 90%. And in a normal distribution, you cover 65% of the sample in this area, right? So this area between this and this represents 65%. The next thing is that 1 more standard deviation, in this case, it's going to be, let's assume it's 99. And here is 80. 1 more standard deviation, you should have around 95% of your observations, right? If you check, where we can talk about this in the lecture, but I'm going to tell you the assumptions of normal distributions. But it's basically that in the middle of your graph you have the mean. That means to the right is 50%, to the left is 60%. 1 standard deviation to the right and to the left, you have 65% of your sample, another standard deviation, and you reach 95% of your sample. That is how a normal distribution looks like. So in order to assume normal distribution of your sample, you want to test if your variable looks like this. So let's go to the histogram that we have in the presentation. We have this histogram. Does it look like normal distribution? Normal distribution should look like this, right? Something like that. Does it look like that? No, not at all, not even close. So we can assume there is no normal distribution. So it looks like, it should look like this, but it looks like this, right? So we have 2 measures or 2 measures to when we want to talk about normality. So the first one is skewness. Skewness refers to how far it is to the left or to the right. So for example, in our case, our histogram moved to the left, right? To the left. Am I correct? Yeah, it moved to the left, like this. So when it is on the left, we say that it is positively skewed. That's how we call it. When it's to the left, it's positive, positively skewed. Positive doesn't mean that it's good, it's just positive. It means that it's skewed to the positive side. And then we have the other one. If it is to the right, we say that it's negative, negatively skewed. So When you report that your distribution is not normal in your variable, you can even say that it is positively skewed or negatively skewed. That is something important. And usually when you have something positively skewed, it looks like this, that the mean is like here. That is exactly what happened with our variable, that we have a mean very far to the right. The median should be around here and the mode should be around here. It looks usually like this, because in here in the normal distribution, mean, median, and mode should be the same ideally, or at least very close. If it is the other way around, it should be negative. And the other way, the other thing that we can show about normality is something that we call kurtosis. And kurtosis is not about if you move it to the left or to the right, but if it moves up or down, okay? So if you have something that looks like this, like it's very flat and then it's very high and then it goes low again. So this doesn't look like the normal distribution, because normal distribution is more like a not that extreme slope, right? So if it looks like this, like a big mountain, it is positive kurtosis, okay? If it's the other way around, like if you have something like this, like it's very low, then that will be negative kurtosis. And you can show it in your study that your variable is positively skewed, and then you can even have both. I think that's what we have in ours. We have positive skew and positive kurtosis, because it looks like this, right? Huge thing, big mountain, but on the left. So positive, positive. So that's kind of sad for what we're going to do later, that we don't have normal distribution, because normal distribution will help us to use more simple analysis later. But anyway, with that, we are done for this. Just one quick thing. Apart from the graph, and you can even mention it in the text, is positive skewed and positive kurtosis. You can also calculate some values for normality, and you are going to learn that in the quantitative lab. But so far, remember what measures for normality is. So let's finish the video here, and we are going to start with the next thing, that is inferential statistics, which I think we are going also to learn the basics and then how to do it in the quantitative lab. So it's like the 12th time I've said quantitative lab.